Welcome to Lesson 5 of the Introduction to Python course. In this lesson, we will be discussing iterables with a focus on types of iterables available in Python, lists, tuples, ranges, dictionaries, sets, and the arguments and keyword arguments parameters. Iterables are objects that can return their members one at a time. Now in this lesson, we are going to cover tuples, lists, ranges, dictionaries, and sets. Let's go through some quick definitions first. Don't worry if these definitions seem a bit complex to you right now. By the end of the lesson, you will be able to understand what all of these terms actually mean. So, the first definition that we will be looking at is sequences. Sequences are iterables that can return their members based on their position within the iterable. Some examples of sequences are strings, lists, tuples, and ranges. Second, lists are mutable, which means that they are changeable sequences, similar to arrays in other programming languages. Third, tuples are immutable or unchangeable sequences. Fourth, ranges are immutable or unchangeable sequences of numbers that are often used in for loops. Fifth, dictionaries are mappings that use arbitrary keys to map to values. Dictionaries are similar to associative arrays, which are used in other programming languages. Sixth, sets are mutable or changeable, unordered collections of distinct immutable objects. This means that while a set itself can be modified, the set cannot be populated with objects that can be modified. Now let's have a look at sequences. Sequences are iterables that can return their members based on their position within the iterable. This is what we've seen before. Now, we have learned about one type of sequence, which is a string. Let's have a look at a very simple string that we have been using for a long time. So that is hello world. Now let's have a look at some more types of sequences. The sequences that we will be going through are lists, tuples, and ranges. So as we've seen, Python's lists are very similar to arrays in other programming languages. Lists are created with the help of square brackets. So let's have a look at an example. So let's say we need a list of colors. So we have colors, and then we have red, blue, green, and orange. Now let's have a look at some list methods. So the first is, first we will go through all of these, and then after that we will demonstrate them. So the first is list.append, which would append the value of x to the list. Then we have list.remove, which would remove the first element, which has the value of x, from the list. It throws an error if such an element is not found. Then we have insert I, x. This would insert x at the ith position. Then we have list.count, which would return the number of times that this x appears in the list. Then we have list.index, which would return the index position of the first element in the list, whose value is x, or it would throw an error if such an element doesn't exist. Then we have list.sort, which would sort the list. We have list.reverse, which reverses the order of the list. We have list.pop, which would remove and return the element at the position n in the list. If n is not passed, then the last element in the list is popped. Then we have list.clear, which would remove all elements from the list. We have list.copy, which returns a copy of the list. And we have list.extend, which would append another list onto this list. Now let's see how these commands actually work. So first, let us create our list. So we have colors, and then we have red, blue, green, and orange. And when we print out colors, this is what we get. So this is our list. Now let's say we do colors.append, and we append purple. Now when we print out colors, we get the updated list with purple added to this list. Now let's say we want to remove green. So we'll do colors.remove and we'll specify green. And when we run this, we get all the colors except green. Now, let's say we want to insert a color at a specific position. So we'll say colors.insert, and within brackets, we will specify the position first. In this case, we'll say position 2, and then we'll specify the color, which will be yellow. And then when we run this, we get all the colors with yellow placed at position 2. And if you remember, Python starts counting from 0 rather than 1. So position 2 will be the third position according to us, but according to Python, this is the second position. Now, let's try colors.index, and let's find out the index value of orange. 3. So as we can see, the position of orange is 3. And that is why colors.index gives us the value of the position of orange as 3. Next we have colors.sort, and then when we print colors, it prints out all the colors arranged in alphabetical order. Then we can do colors.reverse, and then print out colors. And we get the same list but reversed. So it goes yellow, red, purple, orange, and blue. Now let's try colors.pop. So first let's try this without specifying any position value. So when we run this, it pops the last value of the list, or rather the last element in the list. Now let's say we do colors.pop, but this time we specify a value, so we'll say 1. So that will pop red because red is at the first position in the list. Now when we print out the list, we get the same list, but we have red and blue missing, and all we have left are yellow, purple, and orange. Now let's try colors underscore copy, which is equal to colors dot copy. This should create a copy of the list. Now when we do colors underscore copy, as you can see, we print out a copy of the original list. Now let's try and append this entire copy of the list to the original list. So we will say colors.extend, and then we will say colors underscore copy, and then we will print colors. So this gives us colors underscore copy appended to the original list, and that's why we get yellow, purple, orange, yellow, purple, orange. Then we have colors underscore copy dot clear, and we print out colors underscore copy. Now this gives us an empty list because we have cleared all of the elements within the list. Now let's say we do del colors underscore copy. Now when we display colors underscore copy, it throws an error because it cannot find that list anymore. That's because we have deleted the list from this entire program. Now let's look a little more into detail when it comes to copying a list. So let's say we have our original list, which is colors, and we have red, blue, green, and yellow. Next, we create colors dot underscore copy, which is equal to colors dot copy. Then we print colors underscore copy. Alright, so now we have our colors list and we have our colors underscore copy list. Now we say colors underscore copy dot sort. And when we print this, we get the list sorted into alphabetical order. Now when we print colors, we still get red, blue, green, and yellow. So we can see that when we sort the copy of the list, nothing happens to the original list. It remains the same. That's because the copy of the list and the original list are two completely different objects. Now let's say we have colors underscore copy 2, which is a new list, which would be a copy of colors. And then we print this, colors underscore copy 2. Next, let's do colors underscore copy 2 dot sort. And when we print this, colors underscore copy 2, we get it sorted. Now when we print colors, we find that colors has been changed as well, and colors has been sorted as well. Now this is quite interesting, isn't it? So let's just do one little thing here. So let's check the ID of colors. Okay, so that gives us some unique number. Now let's check the ID of colors underscore copy. Okay, this is a unique ID as well. Now we'll check the ID of colors underscore copy 2. Now we find that the ID of colors underscore copy 2 as well as the ID of colors is the same. That is because when it came to colors underscore copy, we just made it as a copy of colors, so it was not equal to colors. It was a completely different object. But when we created colors underscore copy 2, what we did was we assigned this variable to another variable, or rather our original variable, which is colors. So instead of making it a copy, the program just created something like a pointer to the original object or the original list. That is why when we modified one of the objects, both of the objects got modified. Now let's see how we can delete list elements. We have already seen how to delete an entire list. Now we'll work with deleting elements within a list. So first let's create our list. So we have colors and let's just, populate this list. So we have red, we have blue, we have green, we have yellow, and we have black. Now when we display this list, we find that we have all our colors all set. Now let's say we type in delete colors and let's specify 0 in the square brackets. Now when we print colors, we find that the first element is gone, or rather the element in the 0th position, which in this case is red, is gone. Now let's say we type delete colors and we say 1 to 3. Now when we print the list colors, we find that the elements from the 1st to the 3rd position, excluding the element at the 3rd position, are removed. So that is the element at position 1 and the element at position 2, which is green and yellow. Both of these elements have been removed, and all we are left with are blue and black. Now let's see how to work with lists. So we'll create 5 more lists with various kinds of elements. So let's say we have list A, consisting of names like John, Peter, and James. Now let's say we have a list B consisting of, this time let's provide some integers. So 1, 2, 3, 4. Now let's consider a list C with float values. So we can have 1.2, 4.5, 6.78. Yeah, I think that should do. Then let's have a fourth list, and let's fill this in with Boolean values. So we'll have true, false, true, true. Finally, let's just throw in a random list E, and let's populate this with all kinds of objects of various different data types. So we'll throw in a name here. Let's put John again. Then we will put integer, and then we will put a float value, and finally we will put a Boolean. Alright, now what we can do is we can print the type of list A. Now let's do the same thing but list B. We'll do the same thing but list C. We'll do the same thing but list D. And finally we'll do the same thing, but it will be for E. Now let's run this code. So you can see that no matter what kind of data type we populate the list with, and no matter how random the list values might be, we can even use different data types within a single list. It will still be considered a list in Python. Now let's have a look at sequences and random. So these are two methods that are used quite often in Python. So the first is random choice, which would return a random element in the sequence. So for example, let us import random first. Then we will create a list called colors, consisting of red, blue, green, and orange. Then we will print this. Alright, now we have random choice with colors, and we can see that the random choice that was made is orange. Now if we try this again, random.choice from colors, it chooses green. So like this, we can randomly choose an element within the list. Now the second method that we can use is random.shuffle. This will shuffle the sequence in place. So once again, let's consider our same library random and the same list. And what we will do here is we will say random.shuffle colors, and then we will print colors. So this randomly shuffles the list. So you can see that instead of red, blue, green, and orange, we have green, blue, orange, and red. And it has not even been sorted in any kind of order. It has just randomly been shuffled around. So these are two important methods that are used with sequences in Python. Now let's get into an exercise. In this exercise, we will be removing and returning a random element. So what we need to do is write a code for the remove random function so that it removes and returns a random element from the passed in list. Then we need to modify the main function so that it uses the remove random function to remove a random element from the colors list and then print something like this out. So this is the sample output. Now, our given code would look something like this. So we would have import random, then we would have the function defined remove random, the list, and after this we would just say pass, because this is where we would need to replace our code. And likewise, we would define the main function, and we would have colors, and we would have a list of colors: red, blue, green, and orange. And once again, this is where we would replace our code. And then we would run main. So this is somewhat how the given code would look. Now, if we wanted to write our solution, which is the entire code, we can take this, and all we need to do is modify this to give us the solution that we need. So first, we remove this line. We say x is equal to random choice, the list. Then we say the list dot remove x. We say return x. Now in the main function, once again we remove that last line, and we say removed color is equal to remove random colors, print f, the removed color was, and within curly braces we specify removed color and then we say print f, the remaining colors are colors, and that's it. So when we run this, we should get the result that we are looking for. There we go. So we get the removed color was blue, and the remaining colors are red, green, and orange. So in this way, we can use the remove and return methods of random element to in this way, we can use the random method to work with the various elements of sequences. Now let's talk about tuples. Tuples are very similar to lists, but they are immutable, which means that they cannot be changed once they are created. Tuples can be created with commas, and they do not require any kind of parentheses. Let's have a look at how we can create a tuple. So let's say we have a variable called magenta, and then we say 255 0, and 255. Now when we call this variable, we find that we get a tuple created with the name magenta, which contains these set of values. But just because we can create tuples without parentheses doesn't mean that we should do it. Usually it's recommended to use parentheses anyway, because sometimes we do need to have parentheses. So let's have a look at an example. Let's say we have a function, show underscore type, object, and then we say print type object. Okay, now let's say we create the tuple but without parentheses, and we say magenta 255 0 255, and then we say show underscore type magenta. This shows us that magenta is of the class tuple. Now let's say that we want to pass this tuple into the function. For this, we would need to use parentheses. So for example, we have show type, and here we put 2 brackets, and then we say 255 0 255. And when we execute this, we get class tuple. If we try to pass this tuple without the parentheses to the function, we will end up with an error. Let's illustrate this very quickly. So if we say show type, and we just put 1 set of brackets, and then we go with 255 0 255, it gives us an error. That is why it is usually recommended that when you're creating a tuple, just go ahead and use parentheses anyway. So just a few things to note here. We created the magenta tuple without using parentheses, but when we passed this tuple to the function, we see that magenta is a tuple. Now when we passed just the tuple without it in the variable, and we constructed it with parentheses, it works fine. But when we constructed without parentheses and we pass this to the show type function, Python passes the values as 3 separate arguments, but since the function expects just a single argument, it throws an error. That is why the conclusion is that we always need to use parentheses when creating tuples. Now, when do we need to use a tuple? Tuples are usually meant to hold heterogeneous collections of data, unlike lists, which are used for holding collections of like data. In a tuple, the position of the element is actually meaningful. Let's have a look at an example. So we'll use our magenta example once again. So let's say we have a variable magenta and we pass the values 255 0 255. And then when we run this, okay, so we've now created our tuple. Now in this case, the values that we pass to the tuple correspond with the RGB color values. RGB is the red, green, blue color values. So when we want to create magenta, we create it by mixing complete red with a complete blue, but no green at all. That is why we have red 255, we have green 0, and then we have blue as 255. Now, some other use cases for tuples include XY coordinates, latitude, longitude coordinates, and geometric shapes. Let's have a look at some examples. So let's say we have a line, and we create a tuple like this. So we have, let's say, minus 40 and 10. Minus 80 and 170. Now let's say we have a triangle and we pass 140 and 200, 180 and 270, and 335 and 180. Then we have a rectangle with 40, 100, 80, 170, 235 and 80, and 195 and 10. So there we go. This is how we can create different kinds of tuples. Now let's talk about empty and single element tuples. So it's unlikely that we would have to create any of these kind of tuples, but just in case we do, here's how we can create them. So let's take a look at how to create an empty tuple first. So let's just create a random variable called t_empty and brackets. That's it. This is an empty tuple. Now if we call t_empty, it displays just a set of parentheses, that's all. That's because this tuple is empty and it contains no values. Now if you want to create a single element tuple, we just need to follow the element with a comma. So for example, if we have t_single as our variable name, or rather our tuple name, then we will say a, comma, nothing. We don't put anything there. So when we run this, we will get t_single, which gives us a single element tuple. Now, if we don't include the comma here, we would just get a string. So for example, let's say we have t1 equal to a comma, and we print type t1. Then let's say we have t2 equal to a, and we print type t2. Now, yeah, actually that's about it. So when we print these, we get the type of t1 as a tuple, but the type of t2 as a string. This is why the comma is absolutely necessary when we want to create a single element tuple. Now let's talk about converting tuples to lists. So converting tuples to lists can be done in this way. Let's say we have a tuple. We'll just call it tuple A, and we will assign it with the elements 1, 2, 3, and 4. Now we say print type tuple A. Next, we will convert tuple A to a list. So let's say we call our list X, and we say X is equal to list bracket tuple underscore A. Now we will print the type of X. Now let's say we want to add an extra element to the list X. So we say x.append 10. Then we want to convert this updated list X to a tuple Y. So we will say Y equal to tuple X. Now we will print this updated value of Y, and we will print the type of Y. Okay, now let's run this code cell. So we see that the type of tuple A is a tuple. Now the type of X is a list. Now Y has these values, because we have appended 10 to it, so it now has 10 included into it. And then the type of y is once again a tuple. Let us now talk about ranges. So a range is basically an immutable sequence or an unchangeable sequence of numbers that are usually used in for loops. This will be covered later under flow control, but for now what we need to know is that ranges are created using range, the range function, which can take either 1, 2, or 3 arguments. Let's have a look at some examples. So let's say we have range stop, then we have range start stop, or we can have range start, stop, and step. So these are the 3 different ways of writing a range command. Now let's have a look at some examples. So we can say print range 10. This will print values with a range starting at 0 and ending at 9. Then we will say print range 511, which will print values starting at 5 and ending at 10. Then we can say print range 0, 13, and 3. Let's give a step size of 3. So this would print the values starting at 0, ending at 12, and in steps of 3. Then let's consider print range, and let's give some values like 4, -4, and let's give the step size as -1. So this would print values starting at 4, ending at -3, and it would be in steps of -1. So when we run this, we get the first output as 0 to 10, range 0 to 10. Then the second one is 511, the third one is 0, 13, and 3, and the fourth one is 4, -4, and 1. Now let's see how to convert sequences to lists. So in order to see how ranges work in Python, the easiest method of doing this is just simply to convert them into lists. Let's see how to do this. So let's say we have list range 10. This would convert the range to a list, and we would get the output that we want. So if you see here, all that the range function printed was 0 to 10 or 5 to 11 and so on. Now if we want to get the actual output, we just need to convert these ranges into lists. So once again, we will do list, and this time we will take the next value, which was 5, 11. And when we print this, sorry, I forgot to put range there. So we say range and add a bracket there. So this prints out the values from 5 to 10. Likewise, we can have list range 0, 13, 3. And when we print this, we get 0, 3, 6, 9, and 12. Finally, we have list range 4, -4, and -1. And when we print this, we get 4 to -3. So we will get a little deeper into ranges once we start discussing loops. Now let's talk about indexing. So if you remember in the strings lesson, we learned how to get specific characters within a certain string by using indexing and also slicing. Now sequences, all sequences, can be indexed and sliced in a similar way. Now just to recap, indexing is the process of finding a specific element within a sequence of elements through the element's position. So if we consider a sequence from left to right, the first element is at position 0, while if we consider a sequence from right to left, the first element, which would be at the rightmost, would be at position -1. So let's take a look at some examples of code with which we can index a list. And the same method can be followed to index any kind of sequence. So let's say we have a list of fruits. So we'll just put some random fruits here. Let's say we have apple, orange, banana, pear. Now, when we want to find the very first fruit, which would be at the 0th position, we get apple. Now, let's say we want to find the fruit at the -1 position. That would give us pear, which is basically the very last element within the list. Now, let's say we want to find the fruit which is at the 3rd position. This would give us pear again, because if you see in this list, pear is at 0, 1, 2, 3, the 3rd position. Now, if we say that we want the fruit at -2 position, it gives us banana, because counting backwards, this is -1, this is -2. So we have pear and then we have banana, and that's why this result gives us banana. So that's pretty much it. That's how we can do indexing with all kinds of sequences. Now let's take a look at an exercise. This is a simple rock, paper, and scissors game. So what we need to do is write a function so that it does the following steps. The first is it should create a sequence with 3 elements, rock, paper, and scissors. Then it should make a random choice for the computer and store it in a variable. Third, it needs to prompt the user with 1 for rock, 2 for paper, and 3 for scissors. Finally, it should print out the computer's choice and then the user's choice. So if you consider a given code, usually it would just be like this. It would say import random, then it would say define the main function, and this is where we insert our code, and then we just call the main function. That's all. So this is basically the general syntax of how we would need to write this code. Now let's take a look at the actual method of writing this code. So we will copy and paste the given code here, and in place of pass, we will start with our code. So let's create a variable called choose, and this will contain a list which would be either rock, paper, or scissors. So this list contains our 3 different options. Now let's call a variable called computer choice. Rather, let's create a variable called computer choice, and we will assign random.choice choose. Next, we have a variable num, which will input 1 for rock, 2 for paper, or 3 for scissors from the user. So this will prompt the user to put either 1, 2, or 3 according to their choice. Now we convert this input into an integer. So we say int num, and then we do -1 to make it understandable to the Python interpreter. Next, we create a variable called user choice, to which we assign choose num. Then we say print computer, comma, computer choice. This will print out the computer's choice. Then we print user, comma, user choice. So this is basically the components of the main function. Now when we call this main function, the computer prompts us for a value. So let's say we go with paper. Now the computer tells us that it chose rock and we chose paper. So that's pretty much it. So we can go on every time we run this code, we can give a different value, and the computer will make a random choice, and it will print out both the computer's choice as well as our choice. Now let's take a look at slicing. So slicing is basically the process of getting a slice or a segment from a sequence and turning that into a new sequence. The syntax for this would be something like this. So we would have subsequence equal to the original sequence, and within square brackets, first underscore position, colon, last underscore position. So this would return a slice that would start with the element that is at the first position, and it would include all the elements up until the element at the last position. However, it would not include the element at this last position. If we leave out the first position and we put only the last position, then it is assumed that the first position is 0 and the computer will start printing from 0. So let's have a look at an example. So let's say we have a list with A, B, C, D, and E. And then we just say colon 3. So we give only the last position and we leave the first position blank. So this would print out A, B, C up until the second position, excluding the third position. Now, if we leave the last position out, it's assumed to be the length of the sequence, starting from whatever the first position is. So for example, let's say we have the same thing, but this time we say 3 colon blank. Now when we run this, we get D and E because it starts from the third position, which is here and here, and it goes on until the end of this list, which is E. Now let's take a look at a few more examples of how to slice a list. So let's go back to our fruit example where we have a list of fruits. They will be apple, orange, banana, pear, and let's add 2 more fruits here. Let's add lemon and watermelon. Now if we say fruit 0 colon 5, this will print out all the values starting from the beginning until the 5th value, which is lemon. Now if we say fruit 1 colon 4, this would print out the values from 1 to 4. So that would be orange to pear. Now if we say fruit 4 colon, we have lemon and watermelon. Now if we say fruit minus 3 colon, we have pear, lemon, and watermelon. Now if we had fruit colon 3, it would give us apple, orange, and banana because it starts from the beginning and then goes on until the 3rd position. Now if we had fruit minus 4 colon minus 1, this would print out banana, pear, and lemon. And finally, What do you think would happen if we did something like this? That's right. Now when we print this would just give us the entire list. So we get apple, orange, banana, pear, lemon, and watermelon, because that is saying that we are starting from the very beginning and going until the very end of the list. Now let's get into an exercise where we will practice slicing sequences. So what we need to do is write a split list function, which would return a list that contains two lists, the first and second half of the original list. So for example, when we pass 1, 2, 3, and 4, the split list function should return 1, 2, and then 3 and 4 as two separate lists. Now, if the original list has an odd number of elements, the function should put the extra element in the first list and should then pass the result. So for example, if we give 1, 2, 3, 4, and 5 as our original list, the split list function should return the first list as 1, 2, 3, and the second list as 4 and 5. So this would be our given code. Now let's see what the solution of this would be. So let's just copy and paste the given code first. Now this is where we would write our function. So within the split list function, first we have list underscore length, which would be the length of the original list. Then we have mid position, which would be mat.ceil list length divided by 2. So this will give us the middle position of the list. Then we have list 1 equal to the original list and we would slice it from the beginning of the list until the mid position. Then we have list 2, which would be the original list. Then we would print this from mid position until the end of the list. Finally, we would return list 1 and list 2 within a list. Now everything else would remain pretty much the same. So when we run this code, okay, so we've run into an error. Right, we have not defined mid pause. That is because I have called this mid position. So let me just change this just to make it a lot easier. And now when I run this, we get the solution that we need. So we get red, blue, and green, and orange, and purple. So this is our list, red, blue, green, orange, purple. So it has been split in such a way that the first 3 elements would come in the first list, and the second 2 elements would come in the second list. So this is how we can slice sequences. Now let's have a look at the min, max, and sum functions. So as you can already tell, the min function will return the smallest value of the iterable. The max function will return the largest value of the iterable. Let's have a look at some examples. So let's say we have a list of colors, the same list as before. So we would have red, blue, orange, green, and purple. Now when we print minimum colors, and then when we print maximum colors, we get blue as the minimum and red as the maximum. Now if we try this with ages, so let's say we have a list of ages. Let's just randomly put ages like 27, 5, 14, 99, 33, and 25. Now, if we print the minimum of the ages, and then we print the maximum of the ages, we get 5 as the minimum and 99 as the maximum. So over here, it found the minimum by finding the one that starts with the lowest value. And over here, it found the maximum by finding the color that starts with the maximum value. So here, blue starts with a B, which is one of the first few letters of the alphabet, so it was the minimum. R comes towards the end of the alphabet, so it is the maximum. And likewise for ages, of course, this is just according to the value of the number. So the minimum number here is 5 and the maximum number here is 99. Another thing to note is that for strings, the uppercase letters are usually smaller than lowercase letters. So for example, if we try to find the min of, let's say something like, okay, a string, and let's just say something like Jill, Andy. So this would print the minimum value to be capital A. Now we will take a look at the sum function. So the sum function, as you can tell, it takes an iterable. It adds up all the elements of this iterable, and then it adds the result to the start if it is passed in. So this is just an optional parameter. So let's take an example. So let's say we have numbers, or rather nums, and we have it from range 1 to 6. Now if we print nums, we get this. So it'll be from range 1 to 6. Now let's say we have sum of nums. So this should give us 15 because it adds 1 plus 2 plus 3 plus 4 plus 5. The result of that is 15. Now if we say sum of nums and we pass in the additional parameter of 10, it will say 25 because it finds the sum of the values within nums, which is 15, and then it adds 10 to it, which would become 25. Now let's see how we can convert sequences to strings with the help of the string.join function. So this method is used to join the elements of a sequence of strings on the given string. So let's have a look at an example. Let's take our original list, colors. In fact, in this case, we can just copy and paste it. So we will take it from here and we will paste it here. But what we will do is we will remove, okay, let's just remove purple for now. And we'll leave it with 4 values. So if we print colors, we have red, blue, orange, and green. Now let's say, within quotation marks, comma, dot, join, colors. This would give us red, comma, blue, comma, orange, comma, green. Now, if we try the same thing, but this time we say comma and then space, and then we do dot join colors. This would give us a comma with a space. So it'll become red, blue, orange, green with a comma and a space in between. Likewise, we can do the same thing. We can put a colon, and then we say dot join colors. That becomes red, colon blue, colon orange, colon green. Now we can just create this with a space and we say dot join colors. This will give us red, space blue, space orange, space green. So the join method will throw an error if any of the elements in the sequence is not in a string, or rather is not a string. In such a case, we will get an error when we try to run this code. So we will now look at how to split strings into lists. To do this, we use the split method. This would split the string into substrings, and by default, it splits on the white space. So let's have a look at an example. Let's say we have a sentence. Love is patient and love is kind. Now let's say we have list of words equal to sentence dot split in parentheses, and then we have list of words. So this would split the entire sentence into various substrings, and this sentence is split at the white spaces. That's why after love it is split, and then after is it is split again, and so on until the very end. Now we can also provide an optional separator parameter which would specify what the separator is. So for example, let's say we have fruit equal to apple, banana, pear, melon. Now if we say fruit dot split and we provide the comma as our separator, it would separate them out into apple, comma, banana, comma, pear, comma, melon. That's because it splits this based on the comma and not on the white spaces. Now there's an extra space before some of these words, before banana, before pear, and before melon. So if you want to get rid of the space, we can specify a multi-character separator, something like this. So if we have the same if we have the same variable here, fruit, with the same values, then we say fruit dot split, and within quotation marks, comma, space, so as you can see, this space over here between the quotation mark and banana and quotation mark and pear and quotation mark and melon is removed when we use the command in this way. So now it just becomes a regular list. Now split also takes another optional parameter, which is max split. This indicates the maximum number of times that we can split the string. So for example, let's say we have once again our variable fruit with the same values. Now let's say we do fruit dot split quotation marks, comma, space, 2. Now when we run this gives us apple, banana, pear, melon, but if you noticed, apple is a separate element, banana is a separate element, and pear and melon are together. That is because we have specified that we only want the string to be split twice, and we don't want any more splits. That is why pear and melon are not separated out. Now let's have a look at the split lines method. Now we'll have a look at the split lines method. So the split lines method of a string, as you can tell, it splits a string into a list on line boundaries. This means that the line feeds and carriage returns are where the string would split. So let's just have a look at an example to make this a little more clear. So let's say we have fruit equal to triple quotes. So we'll shift this there. Let's say we have apple, banana, pear, and melon. And we will shift this up. Now we will say fruit dot split lines. So this will return apple, banana, pear, and melon. Now we'll have a look at the split lines method. So the split lines method is mainly used to split a string into a list based on line boundaries. So let's have a look at an example. So let's say we have fruit equal to triple quotes, send this down, then we will say apple, banana, pear, and orange. Now if we say fruit dot split lines, we get this as our output. So this method is usually used when we have to read files because it makes the reading of files much easier. Now we'll talk about unpacking sequences. So earlier we learned about something called simultaneous assignment, which allowed us to assign values to multiple variables at the same time. So it was something like this. If you remember, we had first name, we had last name, and then we had company, to which we assigned the values Monica, Geller, and Digi Safari. Now when we print first name, when we print last name, and when we print company, we get the required values, which is Monica, Geller, and Digi Safari. Now we can use the same concept when we want to unpack a sequence into multiple variables. So for example, let's say we have something called about me, which consists of Monica within quotation marks, Geller, and Digi Safari. Now we will say first name, last name, and company is equal to about me. Then we will print first name, we will print last name, we will print company. And when we run this, we get the first name is Monica, last name is Geller, and the company is Digi Safari. So in this way, we didn't even have to separately assign anything. All we have to do is take the values from here and assign them in this way and then print them. So it's as simple as that. By unpacking sequences in this way, it makes our programming much easier. Now we will move on to dictionaries. Dictionaries are just mappings that use arbitrary keys to map to values. So in other programming languages, something similar would be associative arrays. Now in Python, dictionaries are created with the help of curly braces and with comma delimited key value pairs. Let's take a look at an example. So let's say we have a dictionary called dict, and within this we use the curly braces first, and then we will define the values of our dictionary. So we have key 1, colon, value 1, we have key 2, colon, value 2, comma, and we have key 3, colon, value 3. And then we close this dictionary. Then we have dict, key 2, equal to new value 2, which would assign a new value to the existing key. Then we would have dict key 4 equal to value 4, and then we print dict key 1, which would print the value of the key. So when we output this, we get value 1. This value 1 is the value of key 1, which is what we have printed over here. So likewise, if we printed the value of key 2, we would have new value 2, and key 3, we would have value 3. Now let's try creating 2 different dictionaries. So let's say we have a dictionary with students' grades, or rather the grades of one particular student for different subjects. So we would call it grades, we would open the, we would put the flower brackets, and we would have the first subject, which we can say is English, colon 97, comma math, colon 93, comma global studies. Okay, let's just make this uniform here. Colon 85, comma art, colon 74, and finally let's have music as 86. Next we say grades of global studies, and let's say that the grades were revised. So the student, instead of getting 85, now ended up with 87. And let's also add another subject here, which is gym. And let's say that the student got 97 in gym. Now let's print the grades, the value of math. So this becomes 93. Now if we print gym, this would give us 97. And if we print global studies, this would give us 87 instead of 85, and so on. Now let's try to create another dictionary. This time let's create a dictionary with personal details. So let's call it Dictionary A, and we will open the curly braces. Then we will have fname, colon Peter, and we will have lname, colon Smith, and we will have age, colon 25. We close this and we will print A first. Then we create B, which is just a copy of A. And then we print B. Now we can add an extra element to the dictionary. So let's add the element of location. So we will say A, and then we will say location. And let's say it's the USA. Now once again we print A. And when we run this code, we find that first A consists of first name Peter, last name Smith, and age 25. Now when we create a copy of A and we print B, it gives the same output. Now when we add an extra element to A and then we print that, we get the same thing, but we have the extra element added, which is the location, as USA. Now let's take a look at some common dictionary methods. So for this, we will be using the same code that we have used here, which is the grades dictionary. Now first we will use dictionary.get. This would return the value for the key if it is in this function. Otherwise, it would just return the default if passed in, or none if it is not. So let's say we have grades.get for English. This gives us 97. Now if we say grades.get for French, it returns nothing because French is not a part of this dictionary. Now if we say grades.get French, 0, it would give us 0. Now let's try the dictionary.pop function. So this would remove and return the value of the key that is specified here. Otherwise, it would return default if passed in, or it would throw an error if it is not. So let's have a look at an example of this. Let's say we have grades.pop English. And then when we print grades, we find that English is missing, but every other value is present. Now if we say, once again, grades.pop English, we get an error because English is no longer a part of this dictionary. Now if we specify grades.pop English and we give the value, or rather the output if English is not present, we get the value not found because English is not in the list, or rather in the dictionary. Now we'll have a look at dictionary.pop item. So this would remove and return the last key value pair that is entered as a tuple. So let's say we have grades.pop item with brackets. This would give us music and 86 because this is the last value that is present in the dictionary. And now when we print grades, we find that it has only math, global studies, and art. Now we can try dictionary.copy, which is basically, as the name suggests, it returns a copy of the original dictionary. So let's create grades_copy equal to grades.copy, and then we say grades English equal to 94, which would add English back to grades, and then we say grades music equal to 100, just a minute, I realized my mistake. For English, the value was 97. Now for music, the value was 86, if I am not wrong. Right, so the value is 86. So now when we print grades, we have these values added back to grades. But if we print grades_copy, we get what we had before, which is just math, global studies, and art, without English and music. Now we have the dictionary.clear function, which, as the name suggests, removes all the elements from the dictionary. So let's say we do grades.clear, and then we print grades. So this would give us an empty dictionary because all the elements have been removed. Now let's say we want to update our dictionary. So we can use the update method to add new key value pairs to the dictionary or to overwrite the values of existing key value pairs or even just existing keys. So this function can take several different types of arguments. So let's consider our original dictionary. Let's just scroll up and we will copy this entire thing and paste it here. Now, there are three different statements that we can use which would modify the value of the math key and that would add a new gym key. So let's see how we can do this. So first we can do grades.update, and within brackets we have math colon 97 and gym colon 93. This is the first statement that we can use. The second statement is grades.update, and we can just say math equal to 97 and gym equal to 93. Finally, we can say grades.update with math, comma 97. I'm sorry, I missed a parenthesis here. All right, so now we can continue. So math, comma 97, one more set of parentheses, gym, comma 93. So when we run this and we print grades, this is what we get. Now, if we use the first statement, we would get the result and the argument would be a dictionary with keys. If we use the second statement, we would get the result as individual arguments, with individual arguments. And if we use the third statement, we would get the result with the argument as a list of tuples. Now let's have a look at the setDefault function. So here's how the setDefault function works. If the key does not exist in the dictionary, then the key is added with a default value. If the key does exist in the dictionary, then the value for the key is left without being changed. Let's have a look at an example. Let's say we have our original dictionary. Let's just copy and paste it from before. Now let's say grades.setDefault and we will say art and we'll put the value as 87. And then we will print art grade, comma, grades, art. Now we will say grades.setDefault gym 97, and then we will say print gym grade, grades, square bracket, gym. So what do you think will happen here? Let's see. So when we run this, we get the result as art grade 74 and gym grade 97. So here's what happened. Since the art grade already existed and the key already exists, there is no change made to it and the art grade remains the same. But since gym does not exist already in this dictionary, it is created and it is given the value 97 as specified before. So basically, the set default command is just telling the computer to add a key unless the key already exists. That's all. So when do we use the set default method? Let's say we needed to create a dictionary of grades. Now we have data that is in some kind of a file or a database that exists. But we can't really be sure about the kind of data that is contained within that particular source, whether it's the file or the database. Even so, we still need grades for 4 specific subjects. So we can populate our dictionary with the help of the external data, and then using the set default method, we can make sure that we have data for all of the keys. So let's have a look at an example here. So let's say we have a variable grades, and to it we assign some kind of a function. Let's just imagine that we have a function called getData. And this function should return the dictionary. Now let's say grades.setDefault, and let's see the values of our dictionary. So first we have English. Let us equate that to 0. Now we can copy and paste the same line of code. Instead of English, we have math. Equate that to 0. Then we have global studies. Equate that to 0. Then we have art. Equate it to 0. And finally, we have music. Also equated to 0. Now, when we run this code cell, we will find that if the key is not included in the dictionary that is returned by this particular function, the getData function, then that would be 0. Now let's talk about dictionary view objects. So there are 3 methods that would return dictionary view objects. The first is dictionary.keys, the second is dictionary.values, and the third is dictionary.items. Now let's try out some examples. So first, let's take the same dictionary as before, which is the dictionary of grades. We'll paste it here and run this. Now let's say grades.keys. This prints out the keys from this dictionary, that is the subjects, English, math, global studies, art, and music. Next, we will say grades.values. When we print this, we get the values from the dictionary. So that is 97, 93, 85, 74, and 86. Finally, when we say grades.items, we get the different key value pairs from the dictionary. So we get English 97, Math 93, Global Studies 85, Art 74, and Music 86. Now one thing to note here is that while these outputs look like a set of lists, they do not have the same operations or provisions as actual lists. So for example, dictionary views do not support indexing or slicing, and that's because they don't have any set order. Also, dictionary views cannot be modified. They give dynamic views into a dictionary, and when the dictionary changes, the views will also change. So let's consider the following. Let's once again print our dictionary of grades. Then we will say grade points. equal to grades dot values, and then we will say print grade points, comma, grade points. Next we will say grades, and we will specify art equal to 97. Sorry, let's make it 87. And then we will say print grade points. Now when we run this, we find that initially we get the values as present within this dictionary. But after this particular command, the value for art changes from 74 to 87 because we have specified it over here. Now there was no need to reassign the grade values to grade points, as grade points provides a dynamic view into the grades dictionary. Now if you want to get a list from a dictionary view, we use the list method. Let's take a look at some examples. So once again, we'll print our dictionary, and then we will say list grades dot keys. And now we get this as a list, and this will provide us with provisions and functionalities that are similar to regular lists. Next we have list grades dot values. Once again, we get a proper list. And finally, we have list grades dot items. And here we get a list of our key value pairs. Now, how do we delete dictionary keys? We can use the del statement to delete a specific key from the dictionary. So let's say we want to delete grades. Let's say we want to delete global studies. So we will say delete grades, and then we will specify global studies. And then when we print grades, we find that our dictionary now only has 1, 2, 3, and 4 values and keys rather than 1, 2, 3, 4, and 5 key value pairs. That's because global studies has been removed from this dictionary. Now we can use the len function to find the number of characters in a string, or to find the number of objects in a list or a tuple or a dictionary or a set. So let's check out some examples. So let's say we have len and we have the string hello. So when we print this, we get 5 because there are 1, 2, 3, 4, 5 characters here. Now let's say we had len and then we had a list of A, B, and C. So when we run this, we get 3 because there are 3 elements within this list. Now let's try len, and this time let's make it a tuple of 255, 0, and 255. Once again, we get 3. Finally, if we have len and we have our dictionary, let's say we put the same dictionary here, and when we run this, right, there's a syntax error. So what we need to do is let's remove this. And we get 5 because we have 1, 2, 3, 4, 5 key value pairs within this dictionary. Now let's take a look at an exercise. In this exercise, we will be creating a dictionary with the help of an input from the user. So first, what we need to do is write a function which creates a grades dictionary and fills it with different grades that are entered by the user for the given subjects. Second, we need to find the average grade and print it out. So one thing to note here is that we need to take the user's input, which will be in the form of a string, and then we need to convert it to an integer in order to perform mathematical calculations with it. So this is a sample output. Now let's see the solution for this. So we will define our function main. We will create an empty dictionary. Then we will say grades, English equal to int input, and then we will provide a question for the user. English grade. Now we'll do pretty much the same thing, except over here we would put math. So we have English, math, global studies, art, and music. So we'll replace this with math, and we'll replace this with math. Once again, the same thing, and this time we put global studies, and here global studies. Once again, this time we will put art and art. And finally, we will put music and music. Okay, so now this will take all the inputs, the necessary inputs from our user. Next, we will define our variable grade points, which is equal to the value of grades dot values. Then we will take average equal to sum of all the grade points divided by the length of the grade points, which is the number of elements within it. Then we will print your average is, comma, average. And that's it. Now when we call our main function, so it prompts us to give a value. So let's say the English grade is 97, math grade is 87, global studies can be 84, art can be 82, and music can be 93. So our average would be 88.6. Now let's take a look at the challenge part of this particular exercise. So what the challenge says is that after printing the average, we should ask the user to change a grade in one subject, and then we should find the new average and print that out. So for this, we would have to prompt the user twice. So let's see how to do this. Let's take the same function that we have created here. And let's make a few changes here. So first, let's define a function called average with grade points. Then we will say average equal to sum of the grade points divided by the length of the grade points. And then we will return the average. Great. Now let's come below this part of the code and let's start afresh. So let's say we have subject equal to input choose a subject to change your grade. Then we will create a variable new grade equal to input, and then we will say what is the new plus subject plus grade. Then we will say grades subject integer new grade, and then we will say average equal to, and then we will pass grade points into our AVG function, and then we will print your new average is, and we will print out the average. Now when we run this, it asks us for our English grade, which again we will just randomly give some scores. So 94, math grade can be 84, global studies can be 78, art can be 82, music can be 93, and it gives us the average. Now it asks us to choose a subject to change. So let's say we want to change our global studies grade. So we will say global studies, and we give a new grade. So from 78, we can make it 81. The new average now becomes 86.8. So as we can see, the program now requires calculating the average more than once. And that is why we have shifted that functionality into this particular function. Let us now move on to sets. As we have seen before, sets are mutable or changeable, unordered collections of distinct immutable or unchangeable objects. So, while a set itself can be modified and changed, it cannot be filled with objects that can be modified and changed. We can also kind of think of sets as dictionaries, in which the keys do not have any values. In fact, sets can be created with curly braces as well, just like dictionaries. So let's have a look at an example. Let's say we have a list of classes. So we put the curly braces and then we add the subject. So it's English, then math, global studies, right, and we have to put the quotation marks, shouldn't forget those, art, and music. Now when we find the type of classes, it is a set. So sets are less common than most of the other iterables that we've learned about, but one great use for sets is to remove duplicates from a list. So let's have a look at an example. Let's say we have a list of vegetables. call it veggies, and we will populate this list with various vegetables. So let's say carrots, potatoes, spinach, and peas. And let's just repeat one of these vegetables. So let's say we have peas again. Now we can say v underscore set equal to set veggies. And then we call v underscore set. So now you can see the extra peas is gone, and all we have left are each unique value, which is carrots, peas, potatoes, and spinach. Now if we want to convert this back to a list, all we have to do is this. Veggies equal to list v underscore set. So now when we call veggies, we get this as a list once again. So usually we can do this in a single step. So let's say we have our original list, which is veggies, populated with carrots, potatoes, spinach, peas, and peas once again. Now we can say veggies equal to list set veggies, which would remove the duplicates, and finally we can call veggies. So we see now that we get the same output and the extra peas is gone. Another way of doing this is just by using the remove duplicates function. So we can say, we can define the function remove underscore dupes, passing the parameter the list. Then we will say return list set the list. Then we have veggies equal to, and in fact we can actually just copy this here, paste it here. Next we will say veggies equal to remove underscore dupes veggies. Then we will say veggies. So now we have the same output that we need with all the unique vegetables in the list, and the extra peas is gone. Now let's take a look at the argument and keyword argument parameters. So when defining a function, we can include these two special parameters, which would accept an arbitrary number of arguments. So first, let's start with the arguments parameter. So this is a parameter that begins with a single asterisk, and it accepts an arbitrary number of non-keyworded arguments and stores them in a tuple. Often the variable is named asterisk args, but we can call it whatever we want. So for example, we can call it asterisk people or asterisk colors. Now, any parameters that come after this in the function signature are keyword-only parameters. Next, we have keyword arguments. So this is a parameter that begins with two asterisks and will accept an arbitrary number of keyworded arguments and will store them in a dictionary. So if you see here, the difference is that the arguments parameter has a single asterisk, the keywords argument parameter has two asterisks, the arguments parameter will accept an arbitrary number of non-keyworded arguments, while the keyword arguments parameter will accept an arbitrary number of keyworded arguments, and the arguments parameter stores them in a tuple, while the keyworded arguments parameter stores them in a dictionary. Now, we often name the variable with double asterisk, and we put kw args, but as with the previous parameter, we can call it whatever we want. So for example, double asterisk people or double asterisk colors. So when this is included, this argument must be the last parameter in the function signature. So the parameters in a function definition need to appear in the following order. First, we start with non-keyword only parameters that are necessary, they basically have no defaults. Next, we have non-keyword only parameters that do have defaults. Third, we have the arguments. Fourth, we have the arguments parameter. Fourth, we have the keyword only parameters with or without defaults. And fifth, we have the keyword arguments parameter. So let's have a look at an example of using the arguments parameter. Now, earlier we had a function that looked something like this. So we define add nums, and then we have num1, num2, num3 equal to 0, num4 equal to 0, num5 equal to 0. Then we say sum equal to num1 plus num2 plus num3 plus num4 plus num5. Then we have print num1, comma, plus, right, so this should be in the quotation marks, the plus sign. Then we have num2, comma, quotation marks, plus sign, num3, comma, quotation marks, plus sign, num4, comma, quotation marks, plus sign, and num5, comma, quotation marks, equal to sign, comma, sum. Now, this would work fine if we know that there will be somewhere between 2 and 5 numbers that are passed into this function. But we can use the arguments parameter to allow the function to accept any number of numbers. So we would do it like this. We would define our function as add nums, and we will pass the parameters as num and asterisk nums. Then we will say total equal to sum nums and num, and then we say print f the sum of flower braces nums and flower braces num is flower braces total Now, after this, we define our main function. So that is add nums 1, 2, add nums 1, 2, 3, 4, 5, add nums 11, 12, 13, 14, and add nums 101, 102, 103, and 404. Now when we call the main function, this is what we get. And this is the output that we required. So 3 things to observe here. The addNums function requires one argument, num. So it can also take 0 or more subsequent arguments, which will all be stored in a single tuple called nums. Now we use the built-in sum function to get the sum of nums and then to add it to num. The output is not exactly perfect, but it can be improved. Now, just a quick glance at the keyword arguments parameter. So this is most commonly used when we need to pass an unknown number of keyword arguments from one function to another. This is pretty useful, but it can be a little complicated, so we will not get into it in this lesson. Alright, so that's it for iterables. So in this lesson, we've learned about lists, tuples, ranges, dictionaries, and sets, and we've also learned about the arguments and keyword arguments parameters. Very soon, we'll learn how to search these iterables for values and how to loop through them, performing operations on each element that are contained within these iterables.